Hey everybody, it's Sunday, March 22nd. The fact that it's Sunday that doesn't matter. You can take care of these whenever you need to. So we are going to get into the next video. We're going to continue on with regression, add a couple more ideas. Okay, so that's me down in the corner. Let's take a quick look at things that made you guys happy yesterday, or I guess that would be Friday at this point. A lot of people playing with their dogs, eating, doing stuff. With family, which is nice. Sorry, just trying to select a nice color here. Let's see. This bottom one here, I don't know if we should be getting batting practice with your boys. As long as you're practicing good social distancing, then I guess that's probably okay. Anyway, reminder, please encourage your classmates and friends to get in and watch these videos. We got to know this stuff, okay? Reminder, if I go too fast, make sure you pause, think, rewind, rewatch if you need to. When you're done watching, feel free to click the like button, leave a nice little review. It makes me feel good on the inside. Okay, so here we are looking at some Ithaca students. We're looking at their weights and heights. I've given us a scatter plot on the left, the residual plot on the right. Okay, so we got to know some vocab. So the explanatory variable, remember, that is the input, that's the x, that's the height. Okay, which means the response variable, that's the weight. All right, and if we're describing the association of the scatter plot, remember those are words. Okay, that's a description. So notice the points generally go upward. Okay. All right. So they kind of fit in that little area over there. We got some scatter. I think linear is the best way to go here. So I'm saying there's a moderate positive linear association. Okay. And look at our residual plot. That should tell us something. All right. So I did all the work. I gave us an equation here. Remember, the model that we're using here is y hat equals b sub 0 plus b sub 1x. And we've got the old plus e at the end, but when we write our models, we don't know what the e is at the time. So anyway, so our slope in context, right, that's the thing in front of the explanatory variable. So for each additional inch a person is taller, on average you would expect them to be about 4.994 pounds heavier. Okay. Remember, take your slope over 1. Okay. Add the units. So if we go up 4.994, that would be up that many pounds. And when we go over 1, that's 1 inch. Okay. Reminder, your y-intercept is 0, negative 195.7. So when we interpret that, again, add units, stick it in a sentence. So if a person's 0 inches tall, you'd expect them to be negative 195.7 pounds, which obviously doesn't make sense. Okay. Reminder, the y-intercept oftentimes doesn't make any logical sense. The slope will, though. Okay. Now, the r value, as you can see here, is 0.8025. So maybe my moderate, again, it's, I don't know, moderately strong, I guess is probably the best way to put that. Remember, like 0.8 is not the cutoff there. All right, so suppose I entered the data wrong. Okay, suppose I put the x's in where the y's go and the y's go where the x's go. Okay, reminder, the correlation equation breaks it all down and looks at z-scores. So suppose, okay, we invert those two things. Notice z sub x times z sub y, or z sub y times z sub x are the same thing. So our new correlation, if we invert those like one of our students did, it is absolutely going to be the same thing. Okay. Now the r squared value, yep, we are going to do two things here. Number one, we're going to take the r value and square it. Okay. But we also just got to double check and make sure our slope, because if our slope is negative, okay, when we square a negative, it's going to end up turning positive. Okay. So we do have to at least consider going from r to r squared to r. More importantly, from r squared to r, but that's just a little foreshadowing for the future. Anyway, so I squared the r value. I got 0.644, which means, remember, we're going to write the sentence. Okay, go back, check your notes. Remember, it's like a little Mad Lib type thing, fill in the blank. So 64.4, the variation in weight can be explained by the variation in height. Okay, so remember the y context comes first, the x context comes second, and the r squared is written as a percent. All right, we're getting there. All right, now, as always, we probably should have done this first, but let's check our conditions and assumptions. Yes, we're dealing with two quantitative variables, height and weight. Okay, yeah, we look at it, our scatter plot right there, straight enough. No, doesn't seem to have any outliers. Now, if we did have outliers, we'd do this process twice, once with, once without, to see what kind of effect it actually has on everything. Okay, and here's what I was mentioning earlier. That's a terrible circle, I know. There we go, much better. Our residual plot does have random scatter. Okay, this time I did not do x versus the residual. Okay, I went y hat versus the residuals. It doesn't matter. Okay, so we do have random scatter, and it does, with the exception of that one up there, we do seem to have that equal variance stuff. It doesn't fan in or fan out or expand or anything. So we are good to go with all this stuff. Okay, I got a little warning here. Watch out for your units. All right, if someone's 5 feet 6 inches tall, how much would you expect them to weigh? Okay, let's do a quick conversion. Since our units, the height is in inches. Okay, well, 5'6" is 66 inches tall. So what I'm going to do is I'm going to take 66 and substitute that in for height. And I'm going to do that using the calculator that we all downloaded because TI was awesome and gave this to us for free. So, all right, so I got it in there, and as you can see, when I hit enter, it'll enter, I promise. There we go. So you would expect them to be about 133.9 pounds. Okay. Doing another one here. Someone now, say we have a relatively tall human, 6 feet 8 inches tall. Again, I'm gonna do the same thing here, just with 6 feet 8 inches tall. That's really tall. That means they probably have to duck going through doorways. Anyway, so 6 feet 8 inches tall, 6 times 12 plus 8 is 80 inches. Okay. So you would expect them to be about 203.8 pounds, again, according to this model. Okay? Now, we've just done two things right there. Okay, now, so as you can see, we did one thing twice, okay? But technically, we actually did two things, okay? I brought back our scatter plot here, so you could see our data, this goes from about 61 inches all the way up to 77 inches tall, okay? 66 is inside that data range, whereas 80 is outside that data range, or it's kind of off our graph a little bit, okay? We would expect these 66 inches to be more accurate because we have lots of data values in and around 66 inches. You would expect the 80 inches to be, well, we don't know. We don't know what that's going to look like because we have nothing anywhere close to that, okay? So when we are making these predictions, when it's inside our data range, that's what we call interpolation, okay, which is often quite accurate and reliable. When we are looking outside our data range, we can do it, okay, but we have to offer up a bit of a warning since it's called extrapolation, okay, it's outside our data range. So we can make the prediction, 203.82 pounds, but we don't really know. Okay, now, it has been brought to my attention, I should have mentioned this earlier when we did the R-squared interpretation, okay, one of the things that might explain the variability in our scatter plot here is the fact that it probably does seem like we have men and women combined here as to be one data set for these Ithaca students, okay? So the person here who's like 61 inches tall and about 90 pounds, probably female, okay? The person who's 73 inches tall, 210, probably male. Yeah. Yep. All right, so one more. So the residual, remember this is the residual E is equal to the actual Y value minus the predicted Y value, okay? So whatever it is, the residual is going to be 205 minus whatever we get when we plug in the height of a 5'10" person, which is 70 inches tall. Sorry, decimal points in the wrong place. It's all good. See? Now it's good. Okay, so notice I'm kind of doing it right in our model here. Okay, so 205 minus whatever the calculator spits out. Okay, and now I got to move that up here because I need some parentheses for this. Okay, so negative 195. To avoid using too many sets of parentheses, notice I'm just using the multiplication symbol for this here. Okay, so that means 51.12. So our residual is 51.12, which means this person is 51.12 pounds more than this model predicts. Okay? All right, so this was a lot. This was a little bit of everything that we've been doing, plus the interpolation, extrapolation. Hopefully you made it this far. Go back to the Google Classroom, try the practice problems, and I will talk to you tomorrow. Peace out, everyone.